Next one we have here, find the coordinates of the stationary point. Once again, I want to show you the question is there. This is question 2b. If h is such that if h is a function or mapping of reals to reals, that's how you define that. H is a mapping of reals to reals, that is from this, the domain is real number, the codomain is real number, defined by h of x equals s cubed minus 3x squared minus 45x plus 7. Find the coordinate of the stationary point. Now the next thing, find the absolute minimum value of the function in the interval absolute value of h less than or equal to 3. Then solve f prime of x equals 0. We do that, but I want to take it one by one. Let's go for the stationary point. Now find the coordinates of the stationary point. This is the function they gave us. Anytime we tell you to find the stationary point, listen please. Number 1, stationary point. Number 2, turning point. These two means the same thing. Let me show you real quick. Now you have a curve. Let's say you have a curve like this. Let me use an ink that will be visible to everybody. Now you have a curve like this. At this point there's movement. At this point there's movement. At the only point that it is not moving is the turning point. And that's how we call it the stationary point. This point is what we call the stationary point. Do you understand? So it can either be like this for concave up curve or a concave down curve. Either of the two, that is where we have a stationary point. Are we alive? I believe somebody here get it already. Now, at this point, let me explain further. At this point, since it is moving, but how is it moving? The curve was like this. It was coming down. It's coming down. At that point, it is coming down. So because it is moving down, you expect a negative value. You're moving down, going down an EU. So definitely the derivative at that point, because at this point it is coming down, we say the function is reducing. If they say, Emmanuel, analyze this curve, emancipate or analyze this curve, what will I say? At this region that is coming down, the function is decreasing because it is going down. At this point that it is going up, the function is increasing. Then what will happen to the third region where it is neither going up nor coming down? Nothing. There is no change. The function is not changing. Then the change in that aspect is 0. And don't forget, change is differentiation. So that is at this point that the function is changing, decreasing, the differentiation is negative. The first order derivative is negative. At this point that the function is increasing, what will happen? The first order derivative is positive because the function, it is changing and it is a positive change. It is increasing. Positive change. It is increasing. So at this point, the derivative at any point here is actually what? Positive, because the function is increasing. And at the point where it is neither increasing nor decreasing, the derivative, since the change is 0, the derivative is change. Change is 0, the derivative is 0. Do you understand? At this point that the function is neither increasing nor decreasing, and that is the point we call either the turning point, because it changed. The turning point, it changed its movement here. From going down, it turned to begin to go up. That's why we call it turning point. Or stationary point, because there's no movement at that point. Either of the two. Anyway, you understand it. That's just what we mean by stationary point. Now we'll continue solving. Now, what do we do for you to get the stationary point? First, we know that is the point where the curve is not moving at all. So what will happen to the derivative? The derivative is 0. Okay, find the first order derivative. That is, find the dy ds of the function they gave you. So when you get the dy ds, the next thing, since you know the function is neither moving up nor down, so set it equal to 0, because we say the derivative at that point to be 0. So we got the derivative of this function by nominal rule. This will be 3x squared. Bring the 3 down. Write the base from if y equals s raised to power n. Then we'll tell you that the dy ds is what? Bring the power down, write the base, reduce the power by 1. So by nominal rule, that is what our brother made easy for us. Are we together now? So now bring the 3 down, write the base s, and 3 reduced by 1, that will be 3s squared. The exponent here is 2. Bring the 2 down to multiply the 3, that will be minus 6. 2 minus 1 raised to power 1. And the same thing, differentiation of a constant is 0, so this one will be 0. And differentiation of something with x, just x, is that number itself. Do you understand? That is, differentiation of kx is actually k. That's what I'm trying to say. Differentiation of ks is k. So that will be minus 45 right there. So the next thing we want to do is set it equal to 0. Set it equal to 0. set it equal to 0 because at the stationary point, we want to find the coordinate. Now set it equal to 0, set it equal to 0. Once we set it equal to 0, then what do? This is a quadratic expression. We need to solve it quadratic wise. And once again, like the one we solved earlier, like the equation I solved, it's in one of our videos. Now, we notice that there's a common number to this, a common factor. And what is that factor? Oh, somebody saying 3. Yes, it's common to everything. So we factored out the 3. And then we want to leave the rest. 3 here we are left with s squared. 3 here we have 2s. 3 here we have 15. So we want to solve this. Now, solving this by factorization. How do I do that? Take the product of these two. The product of that is minus 15. Now, two numbers we multiply to get minus 15. You add to get minus 2. That is obviously minus 5 plus 3. So you know that will be x minus 5, x plus 3. Simple. X join to this, x join to this. That's how we run it. Another shortcut, cap it there. That's one of the things. So that's one of the things you get by watching our videos. So just join x to this, that's x minus 5. Join x to this, that's x plus 3. And those are the factors of our beautiful expression. So that's the factor. Now, so upon that is, we have at our stationary point, we have two values for x. Now, of course, this is s equal to 0, so we'll find the 0. So since s minus 0, I already said it before, and I'm saying it again, we say two numbers multiply to get 0. Then, it is 100% sure that for you to multiply two numbers to get 0, either one of them is 0, or both numbers. If both numbers are 0, 0 times 0 is actually some busy thing, but for you to multiply two numbers to get 0, either of them will be 0. So either the first one is 0, or the second one is 0. So do confirm. If x minus 1 equal to 0, then s is going to be 5. Or if x plus 3 equal to 0, s is going to be minus 3. These 2 points are the stationary point of a function. Somebody is saying, why is it like that? Why is it like that? Don't forget the equation we have is a cubic equation. Don't forget it is a cubic equation. I just want you to visualize whatever it is I'm talking about here. Don't forget we have a cubic equation around here. And having a cubic equation, how will the curve look like? Let me just show you real quick. The curve is going to be, say, like this. So you have stationary point 1, stationary point 2. You get it? Yeah. Don't mind me. One of my guys will say, don't play. That is it. So that is why we have two stationary points. But that's not what they want us to find. Those are not the coordinates. These are the s coordinates at the stationary point. Then what do I do to get the y coordinate at the stationary point? These are the s coordinates at the stationary point. But if you look at this point now, let's say this is one of them. As this one has got x, you can trace it back to y. So every point we have both x and y. That's why we call it coordinates. And even the question is find the stationary point. You stop there. You don't need to look for the s coordinate. Sorry, the y coordinate. The stationary point is s equals to 5 and s equals to minus 3. The stationary points are s equals to 5 and x equals minus 3. But here they said find the coordinate. When you have the right coordinate of a point, you have both the x coordinate and the y coordinate. That's how you get the coordinate of a point. Are we together here now? So what do we do to get a y coordinate? Substitute x equals to minus 3 into this h of x for you to get the y coordinate, because h of s will be equal to y actually. Are you getting what I'm saying now? So what did you do? Substitute it. So that will be minus 3 raised to power 3, minus 3 open bracket, minus 3 all raised to power 2, then minus 4 times minus 3 plus 7. Minus 3 raised to power 3, that's minus 3 times minus 3 times minus 3, that's minus 27. And then this one you get plus 9. Minus 3 whole square is 9. Minus 3 times 9, that's minus 27 still. Minus 45 plus 3, minus 45. Minus 45 minus 3 is actually plus. Minus times minus is plus. Then 45 times 3, 135. I'm sorry, I need to rush a bit. I don't want the video to be too long. I want to get here now. Then the next thing plus 7. Minus 27 minus 27, that's minus 54. And then plus 135 plus 7, just simplify, we got 88 right there. Are we together here? Yeah. So we want to continue with what we have. Yes, we want to continue with what we have. Now we'll continue with this. We continue with this. Now we already get this. So the next thing is substitute 5 into that our function, which is what? S raised to power 3 minus 3x squared minus 45 times x plus 7. So when you substitute it, you get 5 raised to power 3 minus 3 times 5 raised to power 2 minus 45 times 5, then what? Plus 7. When you simplify this, 5 raised to power 3, 5 times 5 times 5, 125. And 5 raised to power 2, 25. Minus 3 times 25, minus 75. Minus 45 times 5, minus 225. Then plus 7. Simplifying that, we got this. Minus 618. Now, the coordinate is, when we substitute minus 3, we get 88. That's one coordinate. X coordinate come before the Y, note that. And when we substituted 5, we got what? Minus 168. So these are the coordinates of a stationary point. These two are the coordinates of a stationary point. Now on to the next question. They say find the absolute minimum value of the function on the interval absolute value of x is less than or equal to 3. What we need to do is just to check that point. Are we together here? This is where we get the question. Obviously, I like doing that, showing my people that the question, this is it here. Find the absolute minimum value of the function on the interval. This same function, that's the same function we're talking about. Now, for you to do this, how do you do it? Now, when they say absolute value of x is less than or equal to 3, then how do you do it? Now, what does that mean? Now, the absolute value of x, this is a bound here. It means absolute now, you know, the absolute value of a negative value is positive, and the absolute value of a positive value is positive too. Note that. The absolute value of minus 3 is 3, and the absolute value of 3 is still 3. What does absolute value mean? It's just like when you have somebody say 5 minus 2, you will say 3. But what of 2 minus 5? You say minus 3. But the real difference between them, the absolute difference, the definite difference between them is 3. It's only that we are saying one is negative, one is greater, one is less. That's the sense we used to have. When you have a small side, hey, small boy, come here. 2 minus 5, if somebody that don't know or understand this concept of one is greater, one is less, I will just tell you directly 3. What is that boy saying? That boy is saying that the absolute value of that thing you think is negative is actually 3. Although it's negative 3, it should have been negative 3. But by absolute value, it makes it positive. The real value, forget about the concept of one is greater, one is less. Okay. Now, that is, if they now give you something that is defined on absolute value, that thing already has two things. Both the negative form of that thing and the positive form of that thing. Then this thing, we go and check x when it is less than or equal to minus 3, and we check x when it is less than or equal to 3. And what do? Put 3 here. We already put minus 3. Don't forget, we got 88 in one of the questions we solved. The previous question. We already put 3, we got 88. Minus 3, we got 88. Now, putting 3 into the function. You know the function is s cubed minus 3x squared minus 45 times, minus 3x squared minus 45x plus 7. So put 3 for x. So h of 3 is going to be 3 cubed minus 3 times 3 squared minus 45 times 3 plus 7. 3 cubed is what? 27. 3 times 3 times 3. 3 times 9 minus 27, and you continue. Here we go minus 28. They said find the absolute minimum value. Already we know h of s. This one is not in the interval. It's not in the interval again because the twin interval we have is here. It's within this range. Within this range. That's what we care about. Now when you look at these two values, one is 88, one is minus 128. Which one is least? Minus 128. So we'll say the absolute minimum value. What it means is, let's assume they said absolute maximum value, it should be 88. Note that, please. Absolute value, maximum value is 88. While the absolute minimum value is minus 128. For you to consider, for you to confirm that, first do for each of, now, first do for this, which we've done before, and do for this, check for the second, check for the first, check for the second. The one that is least there, the least value, that will be absolute minimum value. The highest value, that will be absolute maximum value. Do we understand that? Thank you. So that is the solution to that aspect. Now, on to the next question. That is the one we have here. The one we have here, this part, yes. Solve f prime prime of x equals 0. The first thing we need to do, at least for we to solve it, we need to get f prime prime of s. For we to get f prime prime of s, what do we need to do? Just do what? Differentiate the function twice. Now, this is the first order derivative. The first order derivative, you say, this is the first order derivative here. This is the first order derivative where I have 3, that's h prime of x. That is what 3s squared minus 6s minus 4s. So we need to differentiate it twice. Now, don't forget we said the first order derivative is what? The first order derivative, is 3x squared minus 6s minus 45. So differentiating this again by nominal rule, we get 6s, and differentiating 6s, you get minus 6. And differentiation of a constant is 0. Now they say we should set it equal to 0. Let's see what will happen there. When you set it equal to 0, it means 6s minus 6 equals 0. Then divide both sides by 6, s equal to 1. S equal to 1. And let me say this here. In case in the question, if they say find the inflection point or find the now, since the curve, I do the curve the other time, I said it's having two stationary points. So one of them will be a maximum point, one of them will be a minimum point. For you to investigate that, let me just say this here. For you to investigate that, what you do is to take the second order derivative of, now, like the second order derivative we got for that same function here is 6x minus 6. You don't be putting the point, what you get in your first order derivative. You know there was a point we get, is it not minus 3 and we got 5. So you put minus 3 into this function, see what you will get. So let me just read it here. Although it's not part of the question, let me just read so that some of you will understand what I'm saying. Let me just do it here so that you understand. In case you have that kind of question, you are told to find the minimum point when you draw a curve. Now, how do I know? If you have a cubic function, it will have two stationary points. That's two turning points. If you have a quartic function, that is where the degree of the equation is raised to power 4. You have 3 stationary points or 3 turning points. Then it is up to you to investigate which one is the maximum point or which one is the minimum point. For you to do that, what you do is to take the second order derivative now at x equals the point you get. The first point we have 5 equal 3, and now you will be the one to get it. How do you get it? Take the stationary point, that is differentiate it one time. Once you differentiate it one time, set it equal to 0. When we did that here, we got 5, so that's why I got s equal to 5. Now the second point, you do the same thing, d square y over ds square. Sorry, it should have been d square y over ds square over the x square. D square y, not the y square, please. It's d square y. This one should be d square y. So what do? At that same point, the second point, you get x equals minus 3. So that's what you do. Now how do we do that? Differentiate this the second time. This is what you get. You now put 5 into this place. Put in 5 here. Let's assume I want to do it. That will be 6 times 5, 30 minus 6. I get 24 here. 24, don't mind me. I kind of slim it down. Now put minus 3 into this place. 6 times minus 3, that's minus 18. Minus 18 minus 6, that's minus 24. So now, if you do the second derivative, now here I got a positive value, that's 24. That is where we call the minimum point. Where the second order derivative is positive, that's the minimum point. And where the second order derivative is negative, that's the maximum point. So this point x equals to 5 is the minimum point. Point x equals to minus 3 is the maximum point. Here I got a negative value, that makes it maximum. Here I got a minimum value, a positive value, that makes it minimum. Positive for minimum, negative for maximum. And then what if I get 0? We call that inflection point. What do I say? We call that inflection point. I just need to say that because I don't think there's another question that will make us do the same thing here. And in case you have that in your exam, that will make you ace it easily.